Hello. In today's class, let me state and prove the convolution theorem for Fourier transforms and also the Parseval's identity. Now, let us now understand what is the meaning of convolution of two functions. F of x and g of x defined in minus infinity to plus infinity. You see that I am taking two functions f of x and g of x which are integrable in the interval minus infinity to plus infinity. Then convolution of two functions f of x and g of x defined in minus infinity to and plus infinity. Both of them are defined in minus infinity to plus infinity. The convolution is given by, it is given by it is written as f of x star g of x. This is equal to 1 by square root of 2 pi. It is minus infinity to plus infinity f of t into g of x minus t into dt. So this is the definition of the convolution of two functions f of x and g of x defined in minus infinity to plus infinity. In the case of Fourier transform, we give like this. Now, what is that we have to prove now? Now, first of all, understand that to prove f of x convolution g of x is equal to f of x into f of g of x, that is equal to f of s into g of s. Simple multiplication of the Fourier transform of f of x. So f of x convolution g of x is equal to f of x into f of g of x, that is f of s into g of s. This is what we should prove. This is convolution theorem. So if two functions f of x and g of x are defined in the interval minus infinity to plus infinity, then the convolution is given by f of x star g of x is equal to 1 by 2 pi the integral of minus infinity to plus infinity f of t into g of x minus t into dt. This is given like this. Then the convolution theorem for Fourier transform states that f of x, this is the statement of the theorem. This is the statement of the theorem and this is what we should prove. Now, very simple and straightforward. There is no need to just keep things in your mind and get confused. Just straight application will get you the answer. Now I'll write here, now f of, apply Fourier transform, f of x star g of x is equal to 1 by 2 pi integral of minus infinity to plus infinity. It is f of x convolution g of x e to the power of isx. This is I am just writing the definition of a Fourier transform. This is nothing but the Fourier transform of this function. Here the function happens to be your convolution of the two functions. Now I will write this, just follow how I write this step by step and without any confusion. And you see that I will open a bracket and give the definition of this. See, this is your, call this as your 1. So you must be able to write this in form 1. So what is that you will write? So you will write this as 1 by square root of 2 pi minus infinity to plus infinity f of t into g of x minus t into dt, that e to the power of isx exists into dx using 1. So I have not done anything except that in the place of this convolution of two functions, I have applied the result 1 here. So this is what I get. Then we can always go for change of the integrations. What I am going to do is, so you can change it. See, what I will do here is that 1 by 2 pi, write it like this, it is minus infinity to plus infinity, then f of t into 1 by square root of 2 pi, open a bracket like this. Then you see that it is minus infinity to plus infinity, g of x minus t into e to the power of isx into dx into your dt, put it like this. So I have not done anything, that I have just made I have changed the integrals. F of t has come out here like that, and I have rearranged and I have got this integral here. Now you see that here this is isx, isx. Now let me take this. See, you take this. Now see, let me call that as your I. Now I is equal to 1 by square root of 2 pi, it is minus infinity to plus infinity, g of x minus t into e to the power of isx into dx. So I'll write here, let x minus t be equal to your u. This implies u is equal to minus infinity when t is equal to, tends to minus infinity. When t is minus infinity, u is plus infinity, and u is equal to plus infinity when t is equal to plus infinity. And d, you want here dx, so you see that your yes, your dx will be equal to your du, and that, what is that you want here? X is equal to u plus t. X is equal to u plus t. Now bring everything, all changes here. So it is 1 by square root of 2 pi. This limit does not change, minus infinity to plus infinity, and it is g of u into e to the power of is. In the place of x you can write u plus t into du, u plus t into du. Now you can write this as 1 by 2 pi minus infinity to plus infinity, g of u into e to the power of isu multiplied by e to the power of ist into du. So you can write this as 1 by square, I'll write straight away here like this. This ist t has nothing to do with here because it's an integral with respect to u. So you can take that outside, e to the power of ist 1 by square root of 2 pi into integral of minus infinity to plus infinity, g of u isu into du. So this is nothing but your ist into f of g of u without, sorry, this is f of g of u, that is equal to e to the power of ist into g of u. So you see that I will call this result as 2. So you see that in the place of this I can substitute this 2. Can you understand what I am doing here? So you see that, so I'll write here, therefore we get, see, therefore we get, what is that you get here now? So therefore we get f of x convolution g of x. So this is equal to 1 by 2 pi square root of that minus infinity to plus infinity f of t into, I will write this as e to the power of ist into g of u into dt using 2. So what is that I have done here? In the place of this I have used 2 and I am able to get this result here. Now what is that I will do here? You see that this is a function of u and it has nothing to do here. It is this here. You find everything is a function of t, and therefore you can very well take that outside and you can write this as g of u, and it is 1 by square root of 2 pi into minus infinity to plus infinity f of t e to the power of ist into dt. So this is what you get. So this is what you get here. So you see that what is that? Again, this is nothing but what? This is the Fourier transform of f of t. So what is that you will write here? So in this place you can very well write this as it is g of u into, this is nothing but your f of t. So this is equal to your g of u into f of this is f of g of s. This is g of s. F of e to the power of ist f of g of u, that is equal to g of s. So here you see that this is, so here it is, here it is. Here it is g of s, it is not g of u, it is g of s into dt. And here what is that you will get here? It is g of s, because Fourier transform of is will be a function of s. So what is that you will get here? G of s into f of s. This is yes and this is also yes. So you see that I am able to get. So what is that I have got here? So Fourier transform of the convolution of two functions f of x and g of x will be equal to this one. Okay, are you able to understand how this is done? So this is what I have proved here. See that I have proved this. So this is called the convolution of two functions. This has got a wide application. I will do problems using this convolution of function in the coming days. I will definitely do. Okay. Now let me come to what is called Parseval's identity. So this is all about your proof, state and proof of the convolution theorem. Okay. Now let us do the next one. See, what is this Parseval's identity? Parseval's identity is nothing but, see here it is like this. the Parseval's identity is Parseval's identity states that, see, it is minus infinity to plus infinity f of x modulus whole square dx is equal to minus infinity to plus infinity f of s modulus whole square into ds. So this is the Parseval's identity. Now, see, it's easy to prove, and just follow how I do this problem. And this, they may not ask you the proof of this, but application part is very, very important, and you must know how it is applied. See, I'll write here. See, we know that f of x convolution g of x is equal to f of s into g of s. This implies that f of x convolution g of x is equal to f minus 1 of f of s into g of s. So this is very much, I am taking the inverse of this Fourier transform will be nothing but this function, which is nothing but the convolution of the two functions. Now, so this is what I have. See, what I will do here is that, here, see, so now, what is the definition of this? This is nothing but what? 1 by 2 pi integral of minus infinity to plus infinity f of t g of x minus t into dt is equal to 1 by square root of 2 pi, and this is nothing but what? Minus infinity to, this is inverse Fourier transform. So this is f of s into g of s e to the power of minus isx into ds. So this is the inverse Fourier transform. This is the inverse Fourier transform, and this is the by definition of the convolution of two functions. Now you can take, see, take x is equal to, because I want to get this is what I should prove. This is your Parseval's identity, and this is what I should prove. So I will take this value of x to be, take x is equal to 0. So take x is equal to 0 in 1. Then what is that you get here? Then 1 by 2 pi square root of this. So you can, this 1 by 2 pi is common, that you can very well cancel, no problem at all. So there is no need to write, they will get cancelled, after they are only numbers that they will get cancelled, and you will get what? It is minus infinity to plus infinity f of t into g of minus t into dt is equal to, it is minus infinity to plus infinity f of s into g of s, and e to the power of x is equal to 0 means e to the power of 0 is 1. So you will get this ds. Now, so you see that we know that, I will write, we know that g of minus t, g of t, I will write, see, g of t, I will write first g of t is equal to f of minus t bar, and therefore g of minus t is equal to f of t bar. This bar denotes the complex conjugate of f of t. The conjugate of, yes, the complex conjugate of this g of minus t it's the conjugate of f of t. Now, and therefore what will happen here is that, so in this place and f of g of minus t is equal to f of t conjugate. So this is equal to your f of s conjugate. I hope that you are able to understand. So there is a proof for this. When time comes, I will give you the proof of that also. For the time being, to prove this Parseval's identity, just know this, just apply this, that is more than enough. See, we know that g of t is equal to f of minus t bar. This is a conjugate of f of t, and therefore when you replace this t by minus t, it is the conjugate of f of t. And when you get like this, now you see that this g of s is nothing but the Fourier transform of this. Therefore you see that f of g of minus t will be equal to your, apply f on both sides, f of g of minus t will be equal to f of t, that is equal to f of t conjugate. So this is the conjugate of f of s. Now I'll write here, so substituting in 1, therefore I'll write here, therefore 1 becomes, it is, what does it become now? Minus infinity to plus infinity. It is f of t into f of t bar, and it is your dt is equal to minus infinity to plus infinity f of s into, what is that you get? Because I have written here, see, using these two I am writing here, so it is f of s bar into ds. So this implies it is, see, f of t into f of d bar will be equal to x into x bar is modulus of x squared. See, x into x bar is equal to modulus of x squared, x into x bar. So this is nothing but what? It is minus infinity to plus infinity f of t modulus of square into dt is equal to minus infinity to this one, and it is modulus of f of s whole square into ds. See, even if you get f of t, f of s negative, then also you have to take it as only plus. So this is your Parseval's theorem. So we have proved this Parseval's theorem. So this Parseval's theorem must for which to prove this, necessarily you must know what is the meaning of convolution of two functions, and then convolution of two functions is this. The Fourier transform of convolution of two functions is this. So you write that and you proceed in this way, and just apply this idea that g of minus t will be equal to f of t, that is the conjugate of f of t, and if you, whereas g of t is equal to conjugate of f of minus t, now you replace this t by minus t, so you will get f of t bar. So f of g of minus t will be equal to f of t bar, that is equal to f of s bar. F of s bar, substitute in 1, so 1 it becomes, gives you the Parseval's identity. This is an important one.